Okay, a circular disc with radius, let's write this down, r equals 0.0195 meters. And we are given also q, looks like this one's going to be, oh boy, 2.14 times 10 to the 6th e on one face, circular ring with a width. So call the width w. 30 times 10 to the negative 6 meter, and radius r equals 0.0005 meters. Okay, now we're asked what's the charge on the ring. Now the approximate charge on a ring is E equals Q 4 pi epsilon 0, and I think this here is going to be x squared. Yes. Here says disc, plastic disc. So let's see, we've got this disc here, and one face of it has this much charge. And we have a okay, it looks like we have a disc here. This is going to be fully shaded. Then we have a circular ring on that. With the center of the ring at radius. Okay, I see what it is. So this has a width. Here. I guess we can shade that. And then this is going to be radius r. And then this here is the width w. And we're asked, what's the q on that, son? Leia? Okay. I don't like this formula. For some reason, this formula just does not seem to work very well. Okay, so yeah, we don't need to use this formula even. Here, this is, as it's kind of alluded to, I guess, this isn't really a disc ring problem, right? That is not what we should have actually been looking for here on one face. And see how I drew it here too? Where there's something here, and then we have another thing laying on top. This is actually a surface density problem. So with this, we know that Q is equal to, I think that's the one for surface density times area, right? Yeah. So with this, we need to find the area here of this. And the area here is going to be 2 pi RW. And our R is given here. And our W is given there. So our area we can find right away. And we know our charge. That's given here. So we can already start saying that Q over A is equal to, this is going to be 2.14 times 10 to the 6th E. And then down here, it's going to be 2 pi times 0.0005 times 30 times 10 to the negative 6. I'm getting 22.7. Let's see if this is anything. It is so far off. Something's really bad. We're like a order of magnitudes really, really, really far off. Ah, yes. I forgot to actually plug in the E in my calculator. Okay, this is still very far off. Very far off. Wait. I just assumed that this would be the R. No, that is kind of the R. Starting here. We have this width here. And then this distance is going to be R. So why are we given the big sphere? That's area, and that's charge. Hmm. Oh, okay. We're not asked. This is why the answers weren't looking at. We're not asked to find this. That's how I was solving it. No. We are asked to find charge. So we have the area right there. Now what is the surface charge density? Surface charge density. This we need to find. We need to find this in order to get here. So knowing Q, this is what we're given big R. We're going to know that it's going to be, this is going to be Q over the area pi big R squared. And this is going to be times 2 pi RW. And yeah, pi's will cancel. We have 2 RW. Little q is going to be equal to this. Let's calculate this. This is going to be 0.0195. So it's gonna be 2, the whole q up top right there, times e, and then it's gonna be r squared on the bottom, and then that's gonna be times 2 times 0.0005 times w, which is 30, times 10 to the negative 6. Okay, I'm getting 2.7 times 10 to the negative 17. Something's wrong. It would be the amount of zeros I have in this 5, wouldn't it? Yes, I think I have one too many. This should be 0.005. I think that sums everything up. So now we're going to have this to the negative 16. Yeah, all right. I guess that solves that problem. Really floundered my way through that one. Oh my goodness.